Welcome back to The Explainer. Okay, so today we are looking at an absolute classic David versus Goliath scenario, but this time it's playing out in the realm of artificial intelligence. On one side, we've got the modern giants. We're talking billion-dollar data centers, proprietary cloud clusters, these massive monolithic corporate infrastructures. And on the other side, a consumer-grade laptop. Seriously. Today, we're unpacking Clive Aldred's 2026 white paper on ADEPT. It's a system that fundamentally challenges the entire assumption that continuous AI learning somehow requires a massive hyperscaler.
So I want you to think about this for a second because it's a huge macro-level question. What actually happens when the infrastructure of public discourse, literally what we know, how we search, how we interact with information, is routed through a single centralized server? As we're going to see in this white paper, this isn't just some abstract technical problem, it is a profound sociopolitical vulnerability.
And Aldred kicks things off with this incredibly bold, really memorable declaration. He writes, "ADEPT was not born in a cloud cluster. It was born on a laptop." That right there is the foundational thesis of the entire ADEPT system. The paper sets out to mathematically and structurally prove that a continuously learning, highly capable AI absolutely does not need to be tethered to some corporate cloud.
All right, so here's our roadmap for today. We'll start with the centralization crisis, then move into the political danger, break down the 4 technical failures, explore the sovereign alternative, and finally look at the architecture of autonomy.
First up, Section 1, the centralization crisis, or the threat of the monolith.
The white paper diagnoses centralization as a fundamental architectural flaw. Basically, when intelligence is centralized, it becomes a single point of failure. Aldred calls this the switch vulnerability of a star topology. Because centralized models operate as these closed black boxes, the provider has the unilateral power to just go in and alter model weights, apply hidden filters, or manipulate outputs, completely unseen by the user. Now, contrast that with a sovereign decentralized mesh, where individual nodes interact directly with each other. In that setup, there's no single server to just switch off or silently alter.
Moving right along to Section 2, the political danger of monopoly and coercion.
Okay, so when a single corporation essentially controls the semantic routing of information, meaning they get to dictate what an AI considers to be factual or harmful, they exert massive influence over our shared epistemic landscape. And this creates a huge friction point, which the text calls the regulatory paradox. You have governments and regulators demanding transparency and audits, right? But they're just met with proprietary data and black box weights. The text points out that regulators are basically reduced to just asking for compliance from entities that are economically incentivized to keep their systems totally opaque.
And the white paper models out the really extreme end of these risks too. In regions experiencing state failure or intense authoritarianism, centralized AI can be weaponized. We're talking predictive dissent arrest and highly personalized propaganda. And a targeted population that has no localized, counterbalancing AI is left completely defenseless to verify facts. Again, this isn't just politics, it's an architectural vulnerability that the author is highlighting here.
Let's dive into Section 3, 4 technical failures, or the micro-agitation.
Now, you might be wondering, why can't we just run today's top-tier models on our own machines right now? Well, the paper identifies 4 specific engineering failures that make current frontier models fundamentally incompatible with consumer-deployed edge AI. We've got tokenization scaling, memory traps, orchestration overhead, and a massive hardware fallacy. Let's break those down.
The very first barrier is the compute wall. Standard transformer attention scales quadratically. This means as you feed it more text, the compute required just skyrockets exponentially until it hits this steep, totally unsustainable threshold. Compare that to state space models, which scale in a nice, manageable, linear fashion. The paper argues that sticking with standard transformers and brittle subword tokenization creates a literal computational wall that everyday consumer hardware just cannot climb over.
Then we have the memory problem. To give an AI memory, the industry uses RAG, or Retrieval Augmented Generation, but the pipeline is incredibly bloated. Say you have just a 10 gigabyte raw text file. Well, that has to be stored in an object store, then converted into a 15 gigabyte vector database, and often a 10 gigabyte graph database on top of that. Suddenly, your 10 gigs of data requires 35 to 50 gigabytes of RAM just to be searchable. If you're on a standard 16 gigabyte laptop, this redundancy trap makes true local knowledge management literally impossible.
Failure number 3 is what Aldred calls the orchestration tax. Because modern AI agents are usually orchestrated in Python, passing data back and forth requires serializing it into JSON and then back again. I know, it sounds minor, but this wastes up to 160 milliseconds per loop. Actually, over thousands of decisions, that turns into whole minutes of burned compute. The proposed solution is super fascinating, using a Rust-based, lock-free actor system with shared memory. This slashes the total time down to just 90 milliseconds, with zero serialization waste.
And finally, we hit the GPU A100 fallacy. The white paper argues, and it's a great point, that open sourcing a model's weights does not actually equal democratization if running that model requires a cluster of enterprise GPUs that cost $80,000. If a system demands 80 gigabytes of VRAM just to boot up, it remains entirely inaccessible to 99.9% of the world.
Which brings us to Section 4, the sovereign alternative, redesigning AI from the edge.
So, if the centralized model is politically vulnerable and technically bloated, what is the fix? Well, to break cloud dependency, the paper says a sovereign AI has to rely on 5 absolute killers. It must be hardware agnostic, meaning it runs on whatever you have. It needs data locality, keeping everything locally on your device. It must support peer-to-peer propagation so it can share knowledge without a central server. It requires cryptographic verifiability so you can actually trust the network. And finally, it has to be offline first, meaning it's fully functional even if somebody cuts the internet cable entirely. And that leads into our final section, Part 5, the architecture of autonomy and how ADEPT actually works. This is where we fully meet ADEPT, the adaptive dynamic engine for persistent truth-seeking. What I really appreciate about this white paper is its methodology. It doesn't just sit back and theorize. It diagnoses the centralization failures, architects a blueprint to fix them, and most importantly, it validates these claims on actual, heavily constrained consumer hardware, not some pristine data center server.
Under the hood, the ADEPT architecture tackles those previous bottlenecks head-on. It drops standard tokenization entirely for a byte-level processing pipeline. It solves the exponential compute wall by using a hybrid Mamba-Transformer backbone that scales linearly. And it completely eliminates that Python orchestration tax by using a Rust-based event-driven actor system. The result? Real-time, autonomous operation right on your laptop's existing hardware. It's honestly a fascinating blueprint for the future of localized computing. Which leaves us with a final, really provocative thought from the text to reflect on. As these AI monopolies continue to grow, you kind of have to ask yourself, in the coming years, will your personal devices merely be dumb terminals used to consume intelligence rented from a massive corporation? Or will they become active, independent nodes of sovereign intelligence? The architecture is being built right now. The rest is really up to us.